Hello, welcome back. We'll continue with our discussion with binary search. Today's question is 875, Koko eating bananas. Koko is given n pounds of bananas. Koko is also given some hours to finish all these bananas. Our goal in this question is to determine the speed in which Koko needs to eat to finish all the bananas in the piles. Let's do an example together. Here are the piles of bananas given to Koko. In the first pile, there are 3 bananas and 6 bananas in the second pile, 7 bananas in the third pile, and 11 bananas in the fourth pile. And we are given 8 hours to finish all these bananas. Suppose the eating speed is 1 bananas per hour. The first pile, it would take 3 hours, and the second pile would take 6 hours. Third pile, 7 hours, and then 11 hours for the fourth pile. We add up all these numbers together and we get 27 hours total to finish all the bananas if the speed is 1 per hour. 27 hours is exceeding the time limit of 8 hours, so the speed at 1 per hour would not work. Now let's try a faster speed. If Koko is eating 3 bananas per hour, so the first pile, Koko can finish that pile in 1 hour. And in the second pile, it will take 2 hours to finish that pile. In the third pile, because there are 7 bananas, so the first hour, Koko eats 3. The second hour, Koko eats 3. And now there's 1 more banana left. So Koko needs another hour to eat that banana. In the last hour, there is more time left. However, Koko would not start to eat a fresh pile of bananas within that hour. This is the behavior as stipulated by the question. For the pile of 7 bananas, Koko needs 3 hours to eat that pile. For the last pile, there are 11 bananas. So the first hour is 3 bananas, second hour is 3 bananas, third hour is 3 bananas, and there's 2 remaining. Koko will take another hour to finish the remaining 2. That pile will take 4 hours to finish. So total, Koko needs 14 hours. Which is still greater than the 8 hours that's allowed. So the speed of 3 bananas per hour would not work. Okay, so let's try a faster speed. What happens if Koko eats 4 bananas in 1 hour? The first pile, it would take that 1 hour to finish up. The second pile, it would take 2 hours. The first hour, it will eat 4. And remaining bananas in that pile, which is 2, it will take another hour to finish those. For the 7 banana piles, again, it will take 2 hours. Koko will eat 4 bananas in the first hour and 3 bananas in the second hour. And for the last pile with 11 bananas, Koko will need 3 hours to finish that pile. Total, Koko needs 8 hours to finish all the bananas if the speed is at 4 bananas per hour. So we are good. We can finish all the bananas within the 8-hour limit. And that is the answer. If you have watched video 1 of this series, you will understand this is following a similar pattern. Here we'll try the different speeds. We'll start with speed at 1 banana per hour, and then we'll continue to increase the speed if the hours that we need is not within the limits that was given to us. So we can try 1 bananas per hour, 2 bananas per hour, etc. 1 is the minimum speed that we can try. What is the maximum speed that we can try for this question? So it turns out the maximum speed we can try is the number of bananas in the piles. So the maximum value of the piles array. In this example, the maximum value is 11. So the maximum speed we can try is 11 bananas per hour. Suppose we try a speed that's higher than 11, then every pile Koko will take 1 hour to finish. And having a higher speed does not provide any change in terms of how long he would take to finish all the bananas, because once a pile of banana is finished, Koko is not allowed to start a new pile even though there is more time left. So there's no point trying a speed that's higher than 11, the maximum value of the piles array. Now that we have the range of speeds we can try, instead of a linear search within this range, we can do a binary search. So we will pseudocode the solution for this problem, starting with the binary search template. The low will be 1. The high will be the maximum of the pulse array. In addition, we will have the response parameter. If in the while loop, we are not able to find the speed so that Koko can finish all the bananas within the given number of hours, then we will return this value. I'm going to set the base value of the variable to be 0. So we will have the while loop, while low less than or equals to high, and we'll determine the mid value. Then we'll pass the mid value together with the pulse array and the number of hours that we have into this function called canFinish. And if Koko can finish within this eating speed, which is the mid value, and then we're gonna set the response variable to the mid value because we have final speed that works. And then we're gonna set the high equals to mid minus 1 because now we want to search if we can do a lower speed. However, if Koko cannot finish with the speed that is mid, then we'll search in the upper half of the range where we're gonna set low equals to mid plus 1. This is a pretty standard binary search template. So at the end, we'll return the response. Okay, now that we talk about the pseudocode, we just convert the pseudocode to the real code. Here is the C# implementation of the code we just saw. This code is provided in the GitHub links below. In that GitHub link, I have also included the Python version of this code. Now let's talk about this canFinish function. This function will take in the pulse array. K is the speed for that iteration, and H here is the number of hours that's given to us. When we initiate a count value, this is the number of hours that we will need to finish all the bananas. And then we'll go through different piles of bananas, and we're going to take that speed, which is K, and we're going to do a division. This will give us the number of hours we need to eat that pile. If there is some remainder, then we will add another hours on the clock. So we need another hour to finish that pile. If the total count, which is the number of hours that we need so far, is already exceeding the number of hours allowed, then we know that Koko cannot finish all the bananas. If after the for each loop is done, nothing returns, then we know that Koko could finish all the bananas using that speed. Okay, now let's test if this works. And it looks good. Next time we'll do another binary search problem. Hope to see you then.